Good evening, sir. My name is Prakash. Me and my friends going to present the topic AI in recommender system. Nowadays, as all we know, the world is going to digitalize with a rapid growth, and in the development of information and technology, artificial intelligence plays a vital role to make it more interesting and efficient. We all use internet for searching the information, shopping, booking tickets, etc. But there is a plenty of data available on the internet, so user has to search and find the necessary information each and every time. So it is very difficult and hectic to filter out the internet of user directly in such a huge database. So this topic AI and recommender system is the basis and need to solve this problem. Now we move to next slide. The scope of our presentation is as displayed on the screen, followed by introduction, led to the conclusion and references. So, now let us have a brief look on the introduction of our topic recommender system. So, first thing, what is recommender system? A recommender system is an application that is built to cope up with the problem of information overload and provide an intelligent suggestion on the item to user. For example, if we search a tutorial or a video on YouTube, then it shows there are lots of recommendation video related to that topic. This is an example of recommender system, or we can observe the same scenario in the buying of a product. So the ability of recommender system is to provide an efficient mean to find the relevant item is extremely useful. Now what recommender system does? Then it generates a personalized list of ranked items for user to buy from, where rank of a product is completely heterogeneous sources of data acquired from the user like interest, likes, dislikes and demographics. Now we move forward and look at the basic model of recommender system. So basic model of recommender system is like that we look at the picture depicted at the slide. It shows an abstract way to how recommender system works. First one, interface, database, recommendation engine, then top recommendation that is sent to the user. So user asks for a query or search a information, then system interface send it to the database, then the recommendation engine recommend the related thing to the user. This interface, database and recommendation engine combinedly form a recommender system that we are going to discuss in the next slide. That is our topic. Now when we talk about the classification of recommender system, then it is broadly categorized into four categories. That is first one, collaborative filtering, content based filtering, knowledge based filtering, knowledge based recommender, then hybrid recommendation system. So collaborative filtering, it evaluates the relevance of an item for a user based on the opinion of the member of community. Second one is content based filtering. Such systems are developed on the assumption that items with similar characteristics related in a similar way. Third one is knowledge based recommender. It is a system like recommends product based on the specific domain knowledge. And then fourth one is hybrid recommendation system. This system is a combination of technique used in the above uh, filterings like collaborative filtering, content based filtering and knowledge based recommender. This above system, combination of above system is called hybrid recommendation system. Now my other group members will present the next part of the presentation.
Hello everybody, I am Sreyasree Mandal and I will be presenting a brief background and a few current ongoing examples of the recommender systems in artificial intelligence. There was an emergence of the first analysis paper on collaborative filtering in the mid-1990s. Since then, recommender systems have become an important research area. Recommender systems directly help users to identify products with the aggregation and analysis of suggestions from other users. Recommender systems were first applied in e-commerce to solve the information overload problem caused by Web 2.0, and they extended it to the personalization of e-government, e-business, e-learning, and e-tourism. Hence, it comes as no surprise that nowadays recommender systems have become an absolute necessary feature of internet websites of the big companies such as Amazon, YouTube, Netflix, Yahoo, and Facebook. Now, I will briefly highlight the recent ongoing work on the recommender system in various fields of artificial intelligence. The first one is transfer learning. It is a technique for representing knowledge and reasoning. Second one, reinforcement learning. It is related to reasoning and planning. Then we have natural language processing. It is a technique for communication and perception. Lastly, computer vision. It is used for perception of images. Now, I will briefly highlight each of the topics. The first one is transfer learning. In the field of recommender systems, transfer learning extends recommendation requests from a single domain to multiple domains by exploiting the correlation of several domains. For example, an active user in a movie domain is likely to be interested in books and music related to movies they like. Another example would be a user may have few records in a book category in an online review and rating system, but may have a large number of movie ratings. Thus, an abundance of data in a secondary domain can assist recommendation in the target domain. Now we have reinforcement learning. The reinforcement learning based recommender systems aim to maximize the engagement and satisfaction of users in the long term. The early work studies the balance of exploration and exploitation, which is also known as the bandits problem. The direct implementation would be to recommend the next item with the previous k consumed items. The trade-off between the exploration and exploitation is addressed with linear reinforcement learning with theoretical guarantee. Now we move on to natural language processing. Recommender systems in the movie and star rating domains are well developed. Many fine-grained opinion, mining, and topic modeling methods have already been established in natural language processing, and efforts are increasingly being made to connect these two areas to extract information from the text and incorporate into the recommendation process. Most recommender systems benefit from review information extracted by natural language processing to complement the rating matrix. Lastly, we have the computer vision. The direct application of computer vision is used in the image recommendation, especially in the areas of fashion analysis and products that are highly related to visual appearance, such as clothes, jewelry, and images. The algorithms map images and user preferences. They take advantage of the features extracted from images using deep neural networks and integrate them with existing methods for clothing recommendation. Also, extended research in this area has added low-level features that mimic aspects of the human vision system, such as color and characteristics, into the framework.
I am Habibur Rahaman and I acknowledge my group members. I am discussing on evolutionary algorithm in recommender system. So basically recommender system provides several personalized service supports. Application of AI is making the recommender system more powerful. Some of the important AI techniques that have enriched recommender systems are deep neural networks, transfer learning, active learning, reinforcement learning, fuzzy logics, and evolutionary algorithms, and so on. These techniques make effective use of recommender systems. Evolutionary algorithms form a class of nature-inspired population-based search algorithms for global optimization. An evolutionary algorithm starts with an initial population, which is a set of candidate solutions to a problem to be solved. New solutions called offsprings are generated by applying genetic operators such as crossover and mutation to the parent individuals. Evolutionary algorithms can be used to combine outputs of the multi recommendation algorithms when the recommendation is treated as multi-objective optimization. Application of AI in the recommender system can be broadly classified into three categories, which are multi-objective recommender system, evolutionary optimization of user or profile items, evolutionary optimization of ratings. So evolutionary algorithms are used to optimize these recommender systems by considering multiple performance like accuracy, novelty, and diversity in order to achieve more accurate and diverse recommendations. A memory-based method using multi-objective optimization to find users have been presented by Karabazi in the year 2018. So a technique that has been applied for the application of topsys to the recommender system has been proposed by Karabazi in the year 2018. So this goes as follows. So first the feedback from the target is gathered, then the user item matrix is generated, and then the similarity is calculated using the baseline methods like PCC and CPCC, and then the construction of decision matrix takes place. Then the topsys method is applied to evaluate and rank all the alternative items, and then the recommendation is generated for existing and the new users. So to achieve accurate personalized recommendations, a novel EA with elite population has been reported to find the core users. So an interactive estimation of distribution algorithm has been proposed by Chen et al. In the year 2017 to offer the user recommendation in an interactive user recommendation in an interactive manner. So this is a well-known recommender system based on interactive evolutionary algorithm with data grouping has been proposed by Kim et al. In the year 2011. So there are three stages which you can see: the pre-processing stage, the user evaluation stage, and the interactive evolutionary computation. So the data extraction and grouping is being done, and then the initial population is being we are creating the initial population, then evaluation is done, and then with selection criteria, selection truncation, the if the probability is less than 0.5%, then crossover happens, and then matching, then new population is generated, and this process grows again and again. Techniques of integrating multi-objective, multi-criteria rating into recommender system has been proposed in the year 2005 to handle larger data sparsity problem. So a genetic algorithm has been utilized in the year 1992 by COSA to optimize the weights of the domains. So AI is making the recommender systems more powerful. Application of EAs develop a secure, federated, and interactive recommender systems to reduce communication overheads. EAs can be used to optimize the models in federated learning also, and EAs are creating uh, security more day by day, so that the model is less vulnerable to adversarial attacks such as malicious manipulation of data. So thank you.
Similarity measures. Before recommendation of item to user, we have to check whether there is any chance that user will accept the item. This is what we call checking similarity. If there is no similarity between user and item, or then he will not buy that item. Recommendation system can be categorized in two broad ways: memory-based systems and model-based systems. Collaborative filtering is one of the techniques that we can use to implement memory-based systems, and there is also one also which is called content-based filtering. Model-based filtering, model-based systems can be implemented using regression and classification. Collaborative filtering. Collaborative filtering can be implemented using two ways: item-based approach and a user-based approach. A product is compared to other products. The more similar the interaction of customer between these two products are, the more they fit together and recommended. With the user-based approach, the same happens, but instead of products, customers are compared with each other. A predict function can be used to create a predicted rating for each product with which a customer has not yet interacted. Based on these predicted ratings, product can then be recommended. Content based Content-based filtering is also similar to collaborative-based filtering. In content-based filtering, there is some extra features like preferences. For example, if I listen to mostly pop music, then one of my preferences is the pop music genre, and while recommending me some music or song, there will be pop music also. Downside of memory-based systems. The memory-based system has mainly two downsides. First is cold start. When a new item or user enters the system, then it faces difficulty because no data is available. The computation time polynomially increases with the increase in user or item in the dataset. This is the second downside of the memory-based systems. The content-based filtering can be seen here in illustrative diagram. In content-based filtering, there is only interaction, means the previous history of user is used to predict predict the item that or recommend the item. Model-based systems. Model-based recommendation systems train a learning model to find pattern in the data and determine a parameter vector on future dimension such that the prediction error is minimized. Predicting the rating can be modeled as either regression or a classification problem. Thank you.
Now the last part of this presentation is conclusion and future work. The use of recommender system grows widely into various application areas, which lead user to more concerns about their privacy. As a result, users are reluctant to provide authentic information and preferences when using the system, which on other hand impairs the performance of the recommender systems. The capability of evolutionary algorithm of covering multiple objectives enables its application in developing privacy-preserving recommender system. As we discussed, an approach for predicting the rating using an artificial neural network framework where both collaborative and content-based features are used to train the model. This methodology brings together content, collaborative and metadata associated with rating under the framework of a unified supervised learning model that produces better prediction result than memory-based collaborative filtering recommendation system. This research did not useful as we this research did not use geospatial data of the businesses, but it can play an important role in the development of location-aware recommendation systems. Applying new natural language processing method, we can identify latent factors within the review text to further enhance the quality of recommendation. Many recommender systems focus on methods and accuracy but lack adequate explanation. Although the performance of recommender system is very good, users find them difficult to trust due to opacity and privacy concern. As this is a challenging limitation in many recommender systems, especially techniques such as deep learning or natural language processing. Although recommender systems have achieved great success in the past, the complex and dynamic characteristics that are a feature of big data are not handled well in the systems. Time-aware recommender systems are developed to address this issue. Most of the methods used in time-aware recommender systems, try to accommodate user preferences drift in their models without detecting the drifts. Now, as we come to the future work part of this, current development in the recommender systems focus on providing decision support with a wide range of information related to the metadata of items, images, social networks, and user contributed reviews. In this presentation, we have discussed the various areas of AI that relate to the such systems and chronicle their development. Given that the anticipated recommendations should always meet user requirement while also gaining a better understanding of what interests a broad range of users, we identify several emerging research aspects that will benefit from future research on recommender system. Now here are some references from where we refer to this presentation. Thank you.